Hi all, I would like to show you a unique feature of Tegra 3, our new quad-core mobile processor. The processor actually has 5 CPU cores. The 5th CPU core is used for low power tasks and helps extend battery life. Now let's walk through a few scenarios and I can show you how the 5th core works in coordination with the high-performance quad cores. As you can see, we're using the honeycomb version of Android for this demo, but shortly you'll see this on the ice cream sandwich version. We're also using a production Tegra 3 device, in this case the ASUS Transformer Prime. As you can see, we have a CPU monitor app at the bottom of the screen measuring workload per CPU. The higher the bar, the more work the CPU is doing. There are 5 windows in the tool, each represents a CPU. The 5th core, or companion core, is on the left, and the high performance cores are next to it, labeled 1, 2, 3, and 4. So here we are, in idle at the home screen. As you can see, the 4 cores are off and the 5th CPU core is on, handling screen refresh, background tasks, and keeping the system humming along. Remember that the 5th core is for low power tasks. Keep your eye on that block of the window. The 4 other cores are for high performance tasks. So let's see how this works. First, let's check out photos. When we launch the app, you can see the performance cores spike up so the application loads quickly. Once it's loaded, the cores go back to 0 and the companion core turns on. It will be in this mode for the remainder of the photo viewing. Alright, let's exit photos and check out what videos look like. What's going to happen is a very similar thing. The cores spike up to load the app, then they go to 0 and the companion core turns on. It's pretty neat technology and capability. The cool part is that none of the OS or applications need to be redesigned to take advantage of the 5th core. Alright, now let's exit video playback and check out something else. A similar behavior occurs for web page loading. In this example, we're loading Google News. You can see the performance cores turn on, so the page loads quickly, then turn off and the companion core turns on, so you can read the page with the lowest power consumption. Finally, let's load a game. This will be interesting. In this case, we're loading a new game called Shadowgun. Games are complex applications, and they generally are multi-threaded for loading. In this case, it's doing all sorts of things behind the scenes. It's decompressing all the assets from a pack file, it's parsing mesh data, creating physics objects, creating cloth and particle simulations, just a ton of new and cool stuff. Once you're in the game, the cores continue to provide a great experience. Alright, now let's exit the game. As soon as you quit, the 4 cores go down again and the companion core turns back on. So that's a demo of Tegra 3, and how the 5th companion core works in harmony with the quad cores, with no OS or app modification, to deliver great performance and long battery life. Thanks.